Now the tricky part is, how do you define a rolling action between the ground and the wheel? And that is the crux of this whole problem. Hello, my name is Josh, and I'm an engineer with Forge Product Development. Forge helps clients start and grow their businesses by providing affordable access to effective engineering resources. Monday through Friday, we offer a free engineering helpline live on our social media platforms, where we help answer questions from people just like you. The clips that follow were taken from one of those sessions. I hope you find it useful and enjoy. This looks like a cool project. So the user here, Apprehensive Lock, is trying to model a self-dumping hopper, and we'll watch the video, or a video that I found of the product. So this is what they're trying to model, what they're trying to replicate. And the part that he's having trouble with is the path that this locking pin traces. So we'll watch how it's used. It's loaded up on the forks. All right, so this is what we want to watch here. So as you can see, they're going to pull the cord. It's going to rotate, dump, and then it's going to rotate back and flip back up. Now, the part that they're having issues with is figuring out what this path here is for this locking pin. We'll watch it again. So that pin is what stops the motion of the bucket on both ends. So as you can see here, hits the pin, stops motion, hits the pin again, stops the motion, and then it just rests on the flat here when it's in its rest state. So what they need to do is figure out what path that pin traces through the through this portion here. And I've kind of been calling this the wheel. It's basically two contact areas on either side of the bin that it kind of defines the path that is going to control this shape here, this arc. So let's take a look at how we would do that. All right, so we're in SolidWorks. New assembly. And this part, we're just going to be making some base geometry. So we're going to want a pin. Doesn't really matter the size of the pin necessarily, because we really just want the center points. And we're going to use a ground part just for easier reference later on. And then we're going to make our bucket, or our wheels that go on our bucket, I suppose I should say. So we'll make this something, call it a pin. And then based on the video, that pin is somewhere out over here. Round about there somewhere. And we can always adjust this later on. Okay. Doesn't really matter what the ground is necessarily. So obviously, proper practice would say to make that a fully confined or fully constrained sketch, which wouldn't be difficult, but the tricky part, or the whole reason we're doing this, isn't to do the sketches. So I mean, when you do it yourself, obviously it's better practice to do it a different way, but for brevity, we're going to stick with what we got. So new parts, we're just going to convert in. Again, normally I'd use a derived sketch. Doesn't really matter what our distance is. do something like that. Make our ground. Again, same thing. And then we'll make a pin. And we're going to make that pin slightly longer, just so we can see it through the other parts. All right, cool. So we have 3 parts now, and they're all fixed in space. So we've got our wheel. That's going to define our path. We've got our pin and our ground. All right, we got our pieces. Now the tricky part is, how do you define a rolling action between the ground and the wheel? And that is the crux of this whole problem. So the way we're going to do it is, you're going to bring in another part, and then we're going to just mate this in place using the standard mates, just to locate it for now. So again, that's fixed. And we're going to turn off the red one. The red one is our kind of our base part, which is going to define the shape. And then this second part that we brought in is going to help us establish what the path for the slot is, by allowing it to move. And then we'll be able to cut the slot, or at least put the reference sketch. We'll be able to put a sketch for the reference for the slot into the part, and then it'll be within both the red part, the original one, and the copied one, because they're really the same part. So you can pass information back and forth between the two, even though you have them in different positions. And so that's one of the keys of this method. All right, so the next part is, we're going to add a mate, which is going to be an advanced mate. And we want a rack, or mechanical mate, sorry. It's going to be rack and pinion. So our rack is going to be this. Check that. We got to turn the sketches on. Sorry about that. We got to be able to see the sketches, because it actually runs off of sketches, just like a gear mate would, or a belt. All right, so we mate, mechanical, rack and pinion. Rack is this, pinion is this. Now we can see it still won't move, and that's because we have it fixed in space. So we can go into here and suppress the mates that are blocking rotation. And now you'll see that the part will rotate. But it's not doing it in the way that we want, right? So it's rotating, but it's not staying at the correct height. And another key to this is that we need to define the height of the center of rotation of the wheel. So if we go back into here, we'll see this point here, which we know is 10, right? Because we know what the radius is. So this point will not move vertically when it's rolling, because the center of rotation, or it's the center of the circle that's described here. So we can make a mate that is from the top to this point, set it to distance, and define it as 10. Or whatever your radius is. And now we'll see that when we do the rocking motion, that's exactly what we want, right? Now, one way to control this, you'll see that I can over-rotate it and break it, which isn't good. So one way to control this would be to put another mate on. And we can just use these surfaces here, which is fine. Normally I'd use a plane, but again, for what we have. So we'll do an angle mate. Analysis maybe? Nope. Maybe it won't let us. Ah, here we go. So it looks like it likes the planes better, so don't grab the faces. So the minimum we want is 0. The maximum angle we want is, if you go back and look at the video, it doesn't quite break 90, so we're just going to put 85. And then where it currently is fine. But now we'll have a mate on here that doesn't allow me to go past here and doesn't allow to go past here. So now we can see that we have the motion that we want to describe, right? So that's part of it. Now the question is, how do we trace this path onto the part? This is a less elegant solution. Ultimately, if you're really doing this for something advanced, you'd probably want if you're doing this in a production environment, you would want to figure out the math that describes this slot. And what I'm going to show you is not necessarily the direct math to solve it. It's really using SolidWorks to do the geometry calculations for you. So it won't be perfect. We're gonna have to interpolate between points, but it gets pretty darn close. So we're going to go into here and we're going to create a sketch within our gray part that can move. That part, front, sketch. And what we're going to do is we're going to use the pin to locate the center. We're going to use a point to locate the center point of the pin. And we're going to snap it on there so we know it's correct. And then we're going to remove it and we're going to fix it that point in position. So now you'll see when we get out of here, that point is in the center of the pin location. And if we move this, that point stays in the correct position for the center point at the end at 0 angle. So now you can probably guess where we're going here. We're going to simply just edit that sketch and add points in each position, exactly as we've done. So we do that, we come out, we move it a little bit more. You can do this more gracefully. You can do more points. You can control the angle here specifically. So your points are all equally spaced according to the rotation angle, but just to show you how it works. Now, one issue I have with this solution is that it's not parametric, meaning that since we're aligning, or since we're using the pin, its current location to set these points, but then breaking that relationship and fixing them in space, if you were to move this pin, you would have to do this over again. Now, I don't think that's the end of the world in this problem specifically, because one, you can probably set your pinpoint fairly accurately in the beginning because you know your start and end points, and you can move the pin around and get it right, and then you can go in and interpolate. And 2, tracing that slot, since there's nothing else based on the slot, there's no other geometry or part that you're trying to find like from that slot feature, you could probably solve it fairly close to the end of your model, or you could probably do this like as a last step in modeling and then just cut your slot in as the last feature practically. And you wouldn't, it's not gonna hinder any of your other parts or design or process. So we repeat it. We'll probably just do one more point. Last one somewhere around there. All right, so we have, let's check what this angle is so that we can actually make it the absolute endpoint. So 69.71. So we're going to change this so that we'll change our limit conditions so that our last point on there is, here we go, is correct. There we go. All right, so now we have all of these points that as we roll it through its motion, you can see they're describing where the pin path is. So it's really pretty straightforward. Now we have those points. We'll do it in a different sketch just so as not to mess up the points. And then we're just going to use a curve. Now you want to use a spline, not a style spline. I've tried both. You could use a style spline and just add a whole bunch of points, but it's essentially the same as using a spline in this case. And we just trace this out. There you go. So now we have a curve that more or less traces the path of that pin. And you could obviously add more points and make it and get better accuracy always. But it looks like, say, I mean, we can check it. It's pretty easy to check too. We just add another sketch in here. Oop, not here. We can add a sketch on here, and then you can just measure what's the distance from here to here. And our distance is 8 thousandths. So seeing how that's a giant pin that sits into a slot, and you're really only concerned with the endpoint conditions because the pin will be free floating inside of that slot during motion. You don't want it stopping anything. It's only a hard stop at the end of its track. Within 8 thousandths is pretty good. I mean, that's probably within, I mean, you're going to have tolerance in there anyways so that it doesn't bind. So, you know, it's pretty good for just using SolidWorks as the hammer to do your math calculations. So now you can do there's a couple different ways to cut the final geometry now that we know this curve. Let's see here. One way might be to do a surface off of this, and then you can thicken it probably. You might be able to just do the whole thing for the path maybe. Mid-plane, we make it 1/2 inch. Let's do a cut. Well, lettuce and feature. Yep, there you go. Mid-plane. Do all both. See if it likes that. There we go. And again, you'd add tolerance in there. You'd add, and you'll have to cut circles at the end. But again, that's pretty easy, right? We just go in and use our endpoints that we already described. Now we want to make sure that we're getting the correct endpoints off the sketch and not assigning it to that pin, or they'll end up floating around. Keep wanting to do that. There you go. Actually, check and see. Yeah, they're tangent. You can see how I have my edges set up. This is dashed. So these surfaces are tangent, which is good. And there you go. We have a groove that describes the path fairly quickly without having to do a lot of heavy math. And although it's not parametric, it is fairly stable because it's by itself. So I think that's pretty much wraps this up. I hope if you have any other questions, feel free to ask them in the comments or contact me directly. I'd be happy to help walk you through it again, or some other aspect of the project. Be sure to leave a like and subscribe to our channel. It helps us a lot for sure. Right now we're trying to get 150 followers on LinkedIn. So if you want to go to the Forge Product Development page and follow us on LinkedIn, that would help a ton, so that we can start doing live sessions over there. But I hope you learned something and enjoyed. Thank you.